Hello everyone, welcome back. In this video, we are going to look at the problem LRU cache from lead code. This is a very important problem and it's not an easy one. So make sure you watch till the end. So according to the problem statement, we have to design a data structure that follows the constraints of an LRU cache. LRU stands for least recently used. So basically we are asked to implement the LRU cache class where as soon as we create an object of LRU cache, we'll be given some capacity, which means that we need to initialize our custom LRU cache with that size. Okay. Then we need to implement two methods. First is the get method where we'll be given some key and we need to return the value corresponding to that key. Basically, we'll be storing key value pairs in our LRU cache, and if that key exists in our LRU cache, then we are going to return the value of that key. But if that key doesn't exist, then we will return -1 as mentioned. Another method that we need to implement is put method where we need to insert the key value pairs. So firstly we will check if that key already exists in our LRU cache. If it exists, then we need to update the value of that key, and if it doesn't exist, then we need to add that key value pair to the cache. Also, it mentions that we need to check the size of our LRU cache. Let's say if the number of keys exceed the capacity of the LRU cache, then it means that we need to evict the least recently used key. Okay, so this is the main feature of LRU cache. When required, we evict the least recently used key. Also, it is mentioned that the functions get and put must work in big O of 1 average time complexity. So this is what we need to implement. Now let us see the approach and how we are going to implement this LRU cache class. So firstly, we are going to see what LRU cache represents. Let us consider that this is our computer, and in our computer we are having an LRU cache and the capacity is 3, which means we can store 3 items in our LRU cache. Basically, the purpose of cache is to improve the accessibility. So let's say in this LRU cache, the leftmost end will have the most recently used item, and in the rightmost end we'll keep the least recently used item. Okay, now let's say I access some data item D1. So after accessing it, it will be stored in the most recently used side of our LRU cache. Okay, now let's say again I access some other data element D2. So when I will access this, so now this D2 will be stored in the MRU side and D1 will get shifted. Okay, similarly, let's say again if I access some other data item, let's say D3. So now this D3 will be stored in the MRU side and all the other data items will shift like this. And in the MRU side we will have D3. Okay, now let's say again I access data item D1. I access this data element again. So what will happen is this D1 is already present in our LRU cache. So it will move to the MRU side because we have accessed it. So it will again move to the MRU side and the other data elements will shift. So as you can see, this is how LRU cache works. Whenever we access any element, it moves to the most recently used side. Now let's say I access another data element D4. Okay, but the capacity is 3 and LRU cache is already full, so we cannot place this data element unless we remove one data element from the LRU cache. It means that we are going to remove the least recently used element from our LRU cache. So this will be removed from LRU side. Okay, and other remaining data elements will move one step towards LRU, and then we are going to place this D4 element. So I hope it makes sense how LRU cache works. Let me just clear all these things. So basically these are the three things that we need to implement in our code. So this is the brief overview of what we are supposed to do. Now let us dig deeper and see how it's going to work. We want our get and put method to both work in big O of 1 average time complexity, right? So for that we'll be using a doubly linked list, and along with that we'll be using a map or a dictionary. Now in order to implement the get and put method in big O of 1 complexity, we will use both of them together. So the reason we'll be using doubly linked list to implement LRU cache is because in doubly linked list we can immediately access both the ends of the linked list with big O of 1 time complexity. So as you can see, to implement doubly linked list we are having two dummy nodes. One side of the linked list I have named this node as MRU node, and other dummy node I have named it as LRU node. So basically any data item which we access will be close to this MRU node, and any data item which we haven't accessed in a while will keep gradually move to this LRU node side. Okay, so this doubly linked list will help us to insert and delete data in big O of 1 time complexity. So let us consider an example and let us see both these data structures work together and make our LRU cache functioning possible. Let me just write one example. So let us consider this example here. Let's say the capacity of our cache is 3, and in the beginning our LRU cache is empty, as you can see. And in our doubly linked list basically we are having two dummy nodes. One of them is MRU, which stands for most recently used, and the other dummy node is LRU node. Okay, so the next pointer of MRU node is pointing to LRU, and the previous pointer of LRU node, LRU dummy node, is pointing to MRU node. Okay, let's one by one take these queries. So the first query that we have is put 3 comma 2. It means that we need to insert key 3 and its value will be 2. So firstly what we are going to do is we are going to check if this key already exists or not. So we will check in our cache, but as this key is not present, it means that we don't have to update it, we need to insert it in our LRU cache. Since it is not present in our cache, the next thing that we will do is we will check the capacity of our cache. But as you can see, as the size of our cache is 0 and its capacity is 3, it means that we are having space available. So what we will do is we will create a new node. Okay, and in this node the value we are going to store this key value, and after creating this new node, since we have accessed this key, we want this node to be close to the MRU end of our doubly linked list. So we are going to insert it. The next of MRU node will point to this new node, and previous of this new node will point back to MRU node, and similarly the next of this node will point to LRU node, since this is the first node we are inserting, and previous of LRU dummy node will point back to this new node which we have created. And let's say the address of this new node is A1. So we are going to store this in our map or dictionary. So the key which we got was 3, and corresponding to this key we are going to store the address of the node which is A1. Okay, so now we will move to the next query. Next we need to put key value 4,7. So again we are going to check if this key 4 is present in our cache or not. So firstly we are going to check in our dictionary or map. So as this key is not present, it means that we need to insert this key value in our LRU cache. Next we are going to check the capacity. Since we are inserting a new key value, we need to first check the capacity of our LRU cache. And the capacity is 3, but the current size of our cache is 1. It means that we are having a space available. So we are going to create a new node, and here we are going to store our key value. So 4,7 we are going to store here, and after storing this we will insert this new node towards the MRU end, right? Because we have accessed this key, so whenever we access that key, automatically should move towards the MRU end, which means that it is most recently used. The next of this MRU node will point to this new node, and next of this new node will point to this node which was previously pointed by the next of MRU node. After rearranging our doubly linked list, we will have the new node next to this MRU node in the front. Okay, now let's say the address of this new node is A2. After inserting this key value in our doubly linked list, we will update the dictionary or a map also. So we are going to store this key in our map. So key was 4, and corresponding to this we are going to store the address of the node of this key, so which is A2. Okay, so far so good. So now we need to get the value of the key 6. So here what we are going to do is we are going to check if this 6 is present in our LRU cache. So when we will check our dictionary or map, we will find that this key is not present. All we need to do is return -1. So here in this case we are going to return -1, and we will move to the next query. Next we need to get the value of key 4. So again we are going to check in our LRU cache. We will check if this key is present in our map. So as key 4 is present, so corresponding to this key we will be having the address of the node of this key A2. So what we are going to do is we need to get the value of this key, but also since we have accessed this key 4, we want the node of this key to be towards the MRU end, right? As we have already accessed it, we are having the address of the node A2, so we can directly access this node in the doubly linked list. And what we will do is we will delete this node from this address, and we are going to create a new node with the same key value, and we will insert that new node next to the MRU dummy node, and then later we are going to return the value of that node. So value is 7, but in this case, since the node of this key is already the first node towards the MRU end, so it will look the same after all the deletion and insertion. Now we'll move to the next function call. Now we need to put this key value pair 5 comma 1. So again we are going to check if this key is present in our cache. So we will check our hash map. As this key is not present, it means that we need to insert a new key value pair in our LRU cache. Okay, now as we need to insert a new key value pair, we are going to first check the size of our LRU cache. Since the size is 2 and the maximum capacity is 3, it means that there is still space left in our LRU cache. So again we are going to create a new node, and in that node we are going to store this key value pair, and then we want that node to be towards the MRU end. Since we have accessed that key, so the node with that key value should be towards the MRU end. So we will create a new node and we will store this key value in that node. Okay, and then we are going to place this node towards the MRU end of our doubly linked list. So after rearranging, our doubly linked list will look like this, and let's say the address of this node is A3. So we are going to store the same in our hash map or dictionary also. So we will store this key in our map, and corresponding to this key we will store the address of the node. Okay, so after inserting this key value in our LRU cache, next we need to insert key 3 and its value is 7. So again we are going to first check our map whether this key exists in our LRU cache or not. So on checking we will find that this key already exists. It means that we need to update the value of this key. As I have accessed this key, that's why I want the node of this key to be towards the most recently used end of the doubly linked list. And for that what we are going to do is, firstly we are going to delete the previous node of this key. That we can easily get since in our map we are having the address of the node of this key, which is A1. So in our doubly linked list we are having this node. So firstly we will delete this. Why we are deleting it? Because we have accessed this key. That's why we want the node of this key to be towards the MRU end, as I already said. So we are going to create a new node. We will create a new node, and in that node we will store this key value, and it will be towards the MRU end of our linked list. So on deleting, this address will be cleared. The previous of that node will now move one step towards the LRU end, right? We will create a new node and we will store the same key with the updated value, and it will be towards the MRU end. And I forgot to mention that when we deleted the previous node of this key 3, we are going to erase the entry from our map also. So this entry will be removed, deleted. And when we will create a new node, let's say the address of this node was A4. So now we are going to insert this key in our map again. And corresponding to this key we will have a new address of the node. New address of the new node. Okay. Now moving to the next function call, we have to put key 6 and its value is 11. So firstly we will check in our LRU cache whether this key exists or not. And as you can see, key 6 is not present. It means that we need to insert a new key value pair. So before inserting the new pair, we are going to check whether we are having space or not. So as the current size of our map is 3 and the maximum capacity is also 3, it means that we don't have space. Now at this moment what we are going to do is, before inserting this key value pair, we need to get rid of the least recently used item from our LRU cache. And how we are going to get that? We are using a doubly linked list. Now this is the significance of using a doubly linked list. We can easily get rid of the node prior to this LRU dummy node, right? And then we can create a new node with this key value 6, 11, and we can insert that new node towards the MRU end. Okay, so we will delete this least recently used item. We are also going to remove the entry from our map. So we will get rid of this entry. And the address of that node will be cleared. So this is the new node with key value 6, 11. Let's say the address of this node is A5, and we are going to update our map also. So in our map we will store key 6, and corresponding to this key we will store the address of the node, which is A5, right? So this is how our LRU cache will function. Now moving to the last function call of our example, we need to get the value of key 4. So again we are going to check if this key is present in our LRU cache or not. So we will check our map. As this key is not present, all we need to do is return -1. So this is how our LRU cache class will work. Let me just summarize everything. So we need to implement two methods in our LRU cache class. First method is this get method, where we'll be given a key and we need to return the value corresponding to this key. So firstly what we'll do is we will check in our dictionary or map whether this key is present or not. If this key is not present, we can simply return -1. If this key is present, then in that map or dictionary corresponding to that key we'll be having the address of the node. So what we'll do is, since we have accessed that key, we want that node to be towards the most recently used end of the linked list. We'll be having the address of that node. So firstly we will delete that node. Then we are going to create a new node with the same key value pair, and we are going to insert it towards the MRU end of our doubly linked list. And then we can simply return the value of that key. So this is what we need to implement in our get method. And in next method that we need to implement is put method, where we'll be given a key and a value pair. So again, firstly we will check if this key exists in our LRU cache or not. We will check in our map or dictionary. If this key does not exist in our LRU cache and in our dictionary, it means that we need to insert a new node, and it's a new key value pair. Since it is going to be a new node, we are firstly going to check if the size of our LRU cache, if the size of our dictionary or map is equals to the maximum capacity that we initialized for our LRU cache. If it is equal to the maximum capacity, then it means that we first need to delete the least recently used element from our cache. So we are going to delete the previous node of the LRU dummy node, and then we will create the new node with this key value, and we are going to insert that node towards the most recently used end of our doubly linked list. Okay, and if the size is less than the maximum capacity, it means that there is still some space left. Then all we need to do is insert the new node towards the MRU end. Okay, and let's say if this key already exists in our LRU cache, but we need to update its value. So what we are going to do is, from our dictionary only we can get the address of that node. Okay, so firstly we will delete that node. We will delete the existing node because we have accessed this key, so we want the node of this key to be towards the MRU end. So we will create a new node and we will insert it towards the MRU end. Okay, so this is the summary of what we need to implement in our code. And whatever we do, we will keep updating our dictionary or map. If I am inserting a node towards the MRU end, creating a new node, so all these things we will keep updating in our dictionary or map. Now let us move to the coding section. So this is the Python code. Firstly, as you can see, I have created this node class for our doubly linked list. Each node will comprise of key, a value corresponding to that key, next pointer which will point to the next node, and previous pointer which will point to the previous node. Okay, and this is our LRU cache class. So as soon as we create the object of LRU cache, we'll be given the capacity. So here I have initialized the capacity of our LRU cache, and I have taken one dictionary, or we can say a map, to keep track of the keys in our LRU cache. And here for our doubly linked list, I have initialized the MRU dummy node that I showed you in the diagram. Its key value is -1, -1. Similarly, I have initialized this LRU node, which is again a dummy node with key value -1, -1. And I have made the next of this MRU node to point towards the LRU node, dummy node, and I have made the previous pointer of the LRU dummy node to point towards the MRU dummy node. After this, I implemented the get method where we'll be given the key and we need to return the value corresponding to this key. Firstly, I am checking if this key is present in our dictionary or hash map. If it is present, then I'll be having the address of that node corresponding to that key. So this is the existing node. So firstly, I will remove this existing node, and then I am inserting the same node with the same key value towards the MRU end. So basically, I have written separate remove and insert functions to update our doubly linked list, which we will see in a while. And then I will return the value of that node after inserting it towards the MRU end. And if this key is not present in our LRU cache, we can simply return -1. This was our get method. Next, this is our put method. So here we'll be given a key value pair. So firstly, I am checking if this key is already present in our LRU cache. If it is present, it means that we just need to update the value. So firstly, I am taking the address of the node of that key, and I am deleting the existing node of that key value pair. After removing that node, I am creating a new node with the key, but this time the updated value, which will be given to us in this method. That new node will be inserted towards the MRU end. If our key is not present in our LRU cache, it means that we are inserting a new key value pair. So firstly, I will check if the length of the map is equals to the maximum capacity of our LRU cache. If this is the case, then it means that we need to remove the least recently used item. So here I am removing the previous node of the LRU dummy node. After removing that, I can simply insert the new key value. I have created a new node, and that node will be inserted towards the MRU end of our doubly linked list. And this is our remove method. So basically in this function, we'll be passing a node to be removed from the doubly linked list. So firstly, we are removing the key of that node from our hash map or dictionary. After removing that key, so basically we are making the adjustments in the pointers since we need to delete this current node. So you can take a pen and a paper, and it is very easy to visualize what changes we are making here. And lastly, this is our insert method. where we need to insert the new node towards the MRU end. So whenever we need to insert a node, we are going to insert it towards the MRU end, most recently used end of our W link list. So here, as you can see, again we are changing some pointers. We are inserting it to the next of the MRU dummy node. After that, after inserting the node, we are putting the key of that node in our dictionary also, and we'll be storing the address of the node of that key. Okay, and if I submit this code, so as you can see, it got accepted. I hope the concept was clear, and if you are new to this channel, please consider subscribing and also share it with your friends and juniors. So that's all for this video. Thank you.